Hey, what's up guys? In this video we're going to walk through the base code for the trigBoard project. And in case you haven't seen some of my previous videos on this, the trigBoard contains an ESP8266 along with some specialized circuitry to allow it to sleep at less than 1 microamp. And there's a lot of features packed into this code base that we're going to get into here. But keep in mind that everything you see here can be leveraged into other ESP8266 projects. If you watched my video on the hardware walkthrough, you can even build your own trigBoard, and here's an earlier rev using all through-hole components. So before we get into the code, I just want to show you what this board does. So I'm going to grab my phone here, and we're going to trigger it at the same time I hit the start button. Okay, so it woke up from that sub 1 microamp sleep state, and within 5 seconds or so we get the push notification to my phone, and that says alert, and that's all customizable when you provision the board. So I'm using the Wi-Fi manager to do that. We'll get into that code. It supports OTA. We're working with push bullet to get the push notification out. And I actually have one of these boards on, let's see, my front door, my side door, my back sliding door. Put one on the garage door. I have one on the mailbox. And one of the things too we'll talk about is that this board has a timer. So it actually wakes up once an hour, checks the battery voltage, and if the battery is low, it will send you a notification so that, if the battery just dies and the board is never actually triggered, you would never know. So at least it checks its own battery and it'll let you know if it's getting low. But in some of my projects, I actually utilize that timer to wake up once an hour and collect some environmental data. So I've got a board outside that's actually hooked up to a BME280, and as you see here, it's publishing that data once an hour to Adafruit IO. So that board has both an LMT01, a BME280, so we're getting temperature, humidity, pressure, and we're plotting that over time. So it's kind of like a little mini weather station. And even in the backyard, I've got a board hooked up to an LMT01, kind of cabled a probe out of it, and I'm also reporting that up here as well. So that's rock solid at 100 degrees. And the inspiration there was the other day I went out there and the temperature was at like 50 degrees or something. The breaker tripped on it. So I'm using the triggers built into Adafruit IO here to send me an email if the temperature ever drops below 90 degrees. So something else that's kind of cool. Oh, by the way, another very cool feature it'll be a whole new tutorial coming up, is hooking up the board to a camera. And I actually have this at the office right now. So when it's triggered by the door, it'll actually take a picture and log it to a Slack channel so that everybody in the office can go into Slack and see who's at the door, who came in. So all of that stuff is coming up in future videos, but like I said, this is the base code walkthrough. So we're going to go through this stuff one feature at a time, walk through it, every line of code here, and here we go. Okay, so just before we jump into the code here, I want to quickly brush on setting things up. So if you go down to the description below, there's a link to the wiki page for the trigBoard. And if you go here, there's a ton of information specific to the trigBoard, but also how to set up the Arduino IDE so that you can take this code and upload it to an ESP8266. So right here is where you go to download the code we're talking about today, and then everything you need to do to set up your IDE, because it doesn't come with the boards manager package for the ESP8266. You'll also need to download and install 2 external libraries to work with this. So once you have all of that set up, then you're good to go. Load the code up, and once you have the correct board selected, which by the way I'm using the Adafruit Husa, and that's just because I've done all of my development so far on that board. So we're going to use that board and go ahead and first verify that we can successfully compile. So I click that. you should see done compiling, so you know we're good. Then we can upload. And then just because there's a lot of functionality in this code on certain things like uploading and the captive portal, I'm going to go ahead and just walk through that very quickly here. So I know I'm dragging this on, and it's going to probably be a long video. But first, let me just show you a couple more things of what the code can do here. So on a trigBoard, I'm first going to just plug in a sensor. And because the trigBoard has the timer on board, we actually have to make sure that the board is in the normal state. So if it wakes up on the opening of a contact, so the contact is normally closed, then the contact should be closed in that normal state before you apply power. And that's so that the timer can correctly set itself for a 1 hour interval, okay? If you don't do that, it'll wake up at random times. It could be 2 hours, 3 hours, or whatever. And you can go back to the hardware walkthrough video for more information about that timer. So anyway, okay, so I'm going to go ahead and plug in the battery now. Okay, so now we've got the battery, and I'm going to upload the code using a USB to serial converter. The jumper settings are set for 3.3 volts and power off. So we'll go ahead and plug this in to the board. And then I need to wake the board up. I've got a wake button, I have a GPIO 0 button, and a reset button. These are kind of hard to get to. Sometimes I'll actually use an LED or the end of a Q-tip or something like that to work with them. Obviously, if you have a Node MCU or another board with the ESP8266, it's a little bit easier to get to these buttons. Some of them have the auto reset stuff built in so that you actually don't have to do anything. But this board was so dense as it was, so I didn't actually have the space on the board to add that. So anyway, I'm going to go ahead and wake it up, and then I'm going to press the reset button. I'm going to press the GPIO 0 button, and then press and release the reset button a few times, continuing to hold the GPIO 0 button. And then now I can go over here and click upload. Now, note that I've got that serial port here selected, and there you see it's starting to upload, and then at this time I can let go of the GPIO 0 button. Okay, so that's the upload procedure if you're going to use a USB to serial converter, and you can see that it's done uploading. So now if I go ahead, I'm going to launch the serial monitor window, and you see that it then had a timer wake, battery voltage was 4.11 volts. So it gives you a battery readout, and that was just a standard timer wake, and that's what it does after you upload it for the first time like that. If I press and hold the wake button, I can actually force it to wake, or I can wake it up by just removing this magnet here, but I'll just press and hold the wake button for a second, and then you see the LED stays on. Alright, so I just had to adjust my lighting there for a second so that you could actually see what was going on with the LED. But if we go ahead and wake it up again, I'm going to press and hold that wake button down for about a second, and you see that the LED is solid on. And then looking over here at the serial monitor window, we can see that the HTTP server started. So it's actually configuring itself as an access point. And this is where you then go to your Wi-Fi settings and actually connect to trigBoard. Okay, so I'm going to go ahead and do that now. Okay, so we've got the trigBoard portal opened up. I'm going to click Configure Wi-Fi. Okay, and this is all part of the Wi-Fi Manager library, which is incredible. It really is one of the coolest libraries out there for the ESP8266. So by default, when you set it up, usually it's where you would click one of the SSIDs that you want the board to connect to. You click that, put in the password, and that's all cool. But you can also put in custom fields here for other information. So right here is where you put in that token you got out of Pushbullet, and the unique name for the board. It could be front door, side door, back door, and then the message to be sent along, like door opened or whatever, door closed. So that's where you put all that in, then click save. And that's what we're going to talk about too. So I'm going to go ahead and configure this and click save. Okay, so we hit save, and you should now get a message to your device if you have Pushbullet installed on your smartphone as well. So, and I just received alert because that's what my board name was entered in as. Okay, so that's kind of cool. Now I want to show you something else. So once you have that set up, I'm going to go ahead and remove the USB to serial converter because we're done with that for now. And I'm going to close the Arduino IDE. And I'm actually going to press and hold the wake button now and continue to press and hold this until I see the LED start a slow flash. Right there. Okay, and now it's slow flashing, and I let go right when I saw the LED start flashing is when I let go, and now it is slow flashing. So I'm going to relaunch the Arduino IDE. Okay, so the reason I relaunched the Arduino IDE is because now if I go down to Tools, I go to Port, I can see the trigBoard now at its IP address. So this is how you can upload code wirelessly to the board. So it's in OTA mode when it's doing a slow flash like that. So I'm going to select that now, and I can just click upload, and it's going to upload wirelessly to the board. So this is very cool. And I do this all the time because I have boards mounted all over the house. So, you know, I don't want to have to hook up my USB to serial converter when the board is, you know, mounted up in the doorway or wherever else. By the way, it will be in OTA mode for 2 minutes. That's the timeout. It's and also when we had it in AP mode, it'll stay in that mode for 2 minutes as well. And I'll show you in the code where we can change that. Okay, cool. So we just actually uploaded the code, so you see done uploading, and we did that all OTA, over the air. So again, we can test things out. I'm going to go ahead and trigger the board just to make sure. Let's clear all these out. And yeah, we got the notification there. So everything works. Okay, I want to show you one more cool thing you can do here. So we'll go ahead and press and hold the wake button, and we're going to continue to hold it. We're going to see the LED flash. Okay, so right there, and then I'm going to let go, and then it starts to slow flash. So now it's in OTA mode. Now I'm going to press and hold the wake button again. Okay, you see it flash again, and then the LED goes solid. Now it's in AP mode again. So now I can reconnect to it, to its SSID. I can connect to trigBoard and change the trigger message. I can change the board name. I can connect to a different SSID if I want to. So that allows you to just reconfigure the board. And basically all it does when you press that button is reset the Wi-Fi settings. Okay, so we'll talk about that in a second here too when we get to that section of the code. But I think that for the most part covers all of the base code features. So now we're finally ready to jump into the code. Wow, so this video is getting long, so I probably should have made this a multi-part video. In fact, I think I'm going to put something in the description below to where I actually start talking about the code. But anyway, here we go. So just want to point out one thing, that this is the base code. There's a lot in work, and everything from here on out, new tutorials where I'm talking about the trigBoard or anything else having to do with getting through different services like Pushbullet, Slack, Adafruit.io, using the camera with the ESP8266, all of those different things I will start from this code here. In fact, there's a lot even in here that I think I can improve on, as you'll probably notice as we work through this. But anyway, okay, so here we are in the code. You can see that it's laid out pretty nicely. You've got everything broken out into different tabs just to kind of keep track of the different functions here, so it's just easier to navigate through. But right up here at the top, we've got all of our includes. Only really 3 pins we're dealing with here. We've got an LED pin. That's pretty obvious. We've got the done pin, and that's what we set high to kill power to ourselves. The external wake pin is what we read on boot up to see what woke us up, the external sensor or a timer wake. Then we've got all of our functions defined right here, and then a whole bunch of global variables. Probably don't have to be global, some of these, but anyway, there they are now. And then all of the action takes place in the setup. Down here in the loop is basically the kill function. This is where we want to kill power to ourselves. So it just cycles the done pin high and low just to make sure that we're dead. Okay, so like I said, everything in the setup, and that's the point of the board really, is to wake up and do what you got to do and go back to sleep. So it only has to happen once anyway. So in the setup here, first thing is set up the serial port. We'll do 115/200, and then immediately check the trigger. So check trigger tab, we go over here, and we've got to check that external wake pin right away. So you might remember from the hardware walkthrough where we went through the different levels for each of the signals and the timing of everything, but we really got to check that external wake pin fast. So we set that as an input right away, and then check it. And if it's low, then we know that it was an external wake. So we set this variable here true, and that is our external wake flag. Then the done pin, might as well set that as an output. We drive that high to kill ourselves, but we'll leave that alone for now. Next thing we do is grab the battery voltage measurement. We only have one analog input on the ESP8266, A0. And this stuff here around it actually scales that to be a voltage for us to read in, so that we're going to have a value here, the raw analog reading, and it's not going to be perfect. So this kind of helps calibrate it. And every ESP8266 is going to be different, so they should be calibrated, and maybe I'll actually include that in a future release of the code, so that on boot up, as long as you give it a known good voltage, it can auto-calibrate to that. But what you're seeing here, though, is a linear equation. So you've got y equals mx plus b, your y-intercept here, and then this is your slope. So basically all I did was take two analog readings at two known voltages. So I took it at 4 volts and 3.5 volts, and then I built this out. And surprisingly, after testing many boards, this has been pretty consistent. So it's not too bad. It doesn't have to be that accurate anyway. So that's what I'm using there. Moving right along here, we got the LED pin there, setting it as an output. It's active low on the board, so when you drive it low, it turns on. So we turn it on immediately, and then we go ahead and tell the world what woke us up. So if it was an external wake, go ahead and print external wake. And if it was not, it was a timer wake. So pretty straightforward there. Then we print out the battery voltage. And then we do this thing here, which is kind of cool. This is a new function for me. But this creates a character array from the float variable here. The battery buff is where we're going to store it as a character array. So battery buff is defined right up here. And we've got 5 characters for that defined there. And then going back, I lost my spot. Battery buff right here. And we're going to give it a length of 3. And we only really need 1 digit after the decimal place. 3.5, 3.6, that's good enough there. And the reason we do this is because I'm going to combine up our entire string that we're going to send out as part of our notification message. So I need everything to be in character arrays, and that's how I'm going to pass it out. And you'll see that later on. So I guess I didn't have to take care of that here now. Could have done that later on, but anyway, there it is. And that's all there is to check trigger. So we bounce out of that. And then right here is where we decide if we send the notification out or not. So if we had an external wake, obviously we want to send the notification. The other case would be if the battery voltage is less than the threshold, which is defined right here, 3.4. So if the battery voltage is less than that, send that out as well. And we also have a separate warning message if that is the case. So we've got some non-volatile memory that we have to read out when we do our push notification, because we are killing power and we are getting our parameters from that captive portal. So we have to save those parameters in non-volatile storage. And for that, I'm actually using, and I'm going to go over to the credentials right here, which is in read. This is that function read file. And to do that, we're using the SPY flash file system. okay? And this code right here was lifted straight out of the Wi-Fi manager library. So I pulled up this example here. This comes with that library when you install it. Auto connect with FS parameters. So it might look familiar right here. So this was lifted right out of there. And, you know, I saw that the example was storing these custom parameters. So I went ahead and did the same thing just with my custom parameters, which you'll see right here, here, and here. And basically all this does here is store those parameters in the SPI flash chip. So we've got this file system for that, and that's why we needed the JSON library as well. So this is pretty cool though, what it's doing here. It's storing it as a JSON config file in memory. It's doing all the checks, it's reading that file out, and then it takes, you know, it's looking for those JSON parameters. We've got trigger message, trigger board name, and token key. And when it finds those, it stores them over in our variable so that now we can use them elsewhere in the code. So those were defined right here. Token key, board name, trigger message, and you see the lengths that I've given those. Going back to credentials here. Now, one thing I found that can be a little wonky with this is if you're using the ESP8266 a lot, maybe in different projects, and you've used the SPI flash for other things and you've stored other variables, you can hose this up, which is why I actually had to add this check here to see if it contained these keys before I go ahead and try to read them out. And if it doesn't have those keys, format. So I actually do a format here. But if you know already that you may have screwed with the SPI flash, you might want to just load a dummy sketch that just formats it out for you anyway. So so we've got the keys now in memory that we can use, and that's all there is to the read file function. Next up, we go to Wi-Fi connection. This is over in provisioning. So we've got Wi-Fi connection right here. We're using obviously the Wi-Fi manager library for that. Fantastic library. There's so much built into that. It's unbelievable that this is, you know, this is available, and just crazy how much stuff they packed into it. Okay, so we'll talk about this in a second, but if we skip that, here is where we add the custom parameters to that captive portal. So we've read these three things out of the JSON config file. So we've got these, and then this is the custom token key, the custom trig board name, the custom trigger message. This is the stuff that we're adding to that captive portal. So if it were blank, if there's nothing in token key, then this would be displayed right here. Okay, and then this is the length. And again, we've got the three parameters we're adding to that. The save config callback function is up here. So it'll call that if anything has changed and it needs to save something new. And then right here is where we actually add the parameters. So we built the parameters up, and then it adds those. So custom token key, trig board name, and then the message. Again, this stuff pulled right out of the examples. So you can see right here, custom thing, and then where they actually added the parameters. So I'm not taking credit for any of this stuff, just showing you how I modified it for my application here, okay? So then we want to have a timeout, and this is set in seconds. So we've got 120 seconds, 2 minutes. And if it never connects, then it fails to connect and hits the timeout, and then just go ahead and write that done pin high. And again, when you do that, it's going to kill power to the board. Okay, and this is the SSID that it's going to launch itself up as, trigBoard. That's why when we went up to our Wi-Fi settings, we looked for trigBoard, connected to it, launched the captive portal, and that's where you entered in all your parameters, saved, and then you got out of there. So after that, then we want to go and grab the value that you put in, that you saved. You see custom T, go get the value out of the portal, and then save those back as token key, board name, trigger message, and then that callback that tells you whether or not to save something would be set. So you have should save call config, which would have been set to true up there. And going back down here, where did I go? Right here. It'll say saving config, and then it builds that out and then puts that back into the JSON config file. You can see here it goes and opens up that file and then actually goes and writes those parameters back in. So again, all of this right from that example, just modified for those 3 parameters that I added: token key, board name, and message. The SSID and password is all handled in the background here of the manager. Okay, so moving right along here, after we take care of all that, we should be connected. So we print out the IP address, and then right here, now we're connected, and now we're ready to send out our notification. So if the battery voltage looked fine, then no worries, we'll send out our standard notification, and this is where we do an sprintf to build out our push message. And we want that to be trigBoard name, the message, and the battery voltage. So you see we're printing that out. This is where the name will go, this is where the message is, and then the battery equal to what we already took care of, 4.2 and then volts. And then we have our function push status to send out that message. It sends out the message with the name, and then the note is part of the way we send it out with push bullet. Okay, so going over to the push bullet tab here, you'll see push status, and I've talked about this in a previous video. In this code, I actually had Richard Johnson, one of my friends, write this code for me. The push bullet stuff itself, the HTTP posts code, came from this link here. And a lot of this stuff has been modified, may even be completely rewritten in future videos, but that's just giving cred to the folks who helped me put this together. So push status right here, this is it. This is where we're passing in, again, the message and the title, and then the type. So going through this, we can work through this a little bit, but this is all part of building out our message. We're doing everything with HTTPS, so we have to set up that post properly, and one of the things you have to do is pass the character count. So in your actual message, how many characters are going to be in it, and you have to first calculate how many characters there are, and that's basically what all of this here is doing. It's working through the message and counting out those characters. Now you might see this here, this VA list and the arguments and VA start. This is kind of cool, and Richard put this together, and I haven't used it yet, but basically what you could do here is pass not just your message, but you can continue to pass other things in here. So if you wanted to like throw all kinds of different things, like I'm thinking of my setup for Adafruit IO, where I'm sending temperature, humidity, pressure, altitude, or whatever else. I could pass all of that. It could be a total custom message, and I could use the same code base for that, because the way he wrote this is that he's combining the message with these extra, it could be, I guess, infinite, as many arguments you want to pass into this. Now, I'm not doing anything with that now, and I may talk about that in the future, but you can see that he's sort of combining everything out and building it. So again, not dealing with that now, so just assume that we're getting that one message in here. So he's going through and counting it out. So that's why we've got this K here, and that's where he's keeping track of the character counts. So just kind of working through. So message type here not equal to the end character for the thing, and it's just while it's incrementing through, K plus plus, K there is in the message type. And then character count is equal to the start word count plus K. The start word count, you'll see, is fixed here at 32. Now, I don't want to get too deep here, but that, if you count out the characters that are already in his body here, so the body, you'll see we have the quote. Oops, we have the little quote there, the body. It includes the bracket here. So if I actually took this, just give me one sec, I'll show you. Okay, so I got it in here and I removed all the escape characters and the anything that I'm passing into it that I'm already counting. So this is the stuff that's already in that string. So let me go back here. So you see that would have been this body, the quotes there, you know, so it's everything that's not part of message title and buff there, okay? So anyway, that's what this whole thing does though, is count up those characters. It works through the message title and the buff. The buff is what the message becomes because, you know, like I said, in his code, he was combining the message body with other arguments, but I'm not using that, so I probably could have just measured, counted up message body. And again, I might revisit some of this stuff. Another note, though, by the way, is that for connecting to PushBullet, we've got our host set up for api.pushbullet.com. The port is going to be 443. So now that we have our total character count right there, we're finally ready to actually start connecting. So we're using Wi-Fi Client Secure to do that. This is an HTTPS connection. So there we go, our host to that port. And then right here we go through and then we start building out our URL. So this is from the API documentation, v2 pushes, and then basically do a client.print here, building up this huge post here. And I do the same thing with Slack. I've done the same thing with Adafruit.io. So it's all this sort of same formatting here. So it's going to be a post plus that URL and then basically building it all out. So there's our access token. Pulls the token out from, you know, that's our variable. That's from the custom parameter we passed in through the portal. The character count, it's going to be in a JSON type format. So this right here is basically a JSON string here that we're passing along. So the body is that our message title. The title there is going to be our message title, which is it's our board name. And then the type is going to be a note. Okay, and then that sends it out. That's as simple as that. And maybe I need to do a separate video just isolating this piece of code, maybe making it a little bit more straightforward. I do need to clean all this up because I'm not really using multiple arguments. If I ever do that, it'll be a separate piece of code. So anyway, jumping back to the provisioning. Okay, so that's where we send the push notification. So that's sent right here. Otherwise, if the battery is low, we send a separate message. It's totally different. So you see the board name, right, goes right there, and then battery low with the actual battery voltage going right there. And then send that message out. And this actually has a different name. It's battery low. And the reason for that is for a couple reasons. It's so that right away on your device, you don't see the board name like side door. You see battery low right on the home screen of your device, because one time I actually had a low battery and I thought I was away, I wasn't home, and I was thinking somebody was trying to break into the house or something. So until I actually opened up the message and saw battery low, you know, I was like, what's going on? So I changed that. So now it says battery low, and then you have to open it up to see which device was actually low. Okay, so that's the same kind of deal there. And then jumping back now, we're out of Wi-Fi. We sent the notification, and then we go back to sleep right here. And this just toggles that done pin a whole bunch of times there, 10 times. And this is kind of cool. This is where all the OTA stuff comes in. So it should be sleeping after this. But if you continue to hold the wake button, it actually will not allow it to go to sleep. So it stays awake and then goes over to the long press function, which is right here. This is where we flash the LED, and this is where you let go of the button. And then this is where it starts up OTA. And then you go over to the OTA. tab and you see where we set all this stuff up. So the host name is going to be trigBoard, like I showed you. May even still be there. Yeah, port trigBoard. So you can set that name to whatever you want, and it'll actually start it up. And this is where it handles the actual OTA begin. And again, this is straight from one of the ESP8266 examples for OTA uploading. Okay, and going back here. So it'll hang out in here for 2 minutes, checking the OTA handle right there, and it does the slow blink of the LED right in here. And if you ever press the wake button during this and it sees that external wake pin go low, then it will flash the LED again, set the reset flag true for that, resetting the Wi-Fi settings, and then actually jump back to Wi-Fi connection. So this is if you want to wipe out the Wi-Fi credentials. So that's when you saw it over here. As soon as you go into this, if it sees the reset flag, reset the settings. Okay, and if it does that, then it will relaunch the portal, because when it gets to this point, where's it at? Oh, I think I passed it. Right here. And this is a Wi-Fi Manager Auto Connect. It won't have the SSID and password, so it will launch its AP, and then when you connect to it, throw up the portal for you to put in the parameters. So going back now to the long press. So if you went to that, it'll jump back here when it's all done, break out of it, and then you're done with long press, and it will go to sleep in the loop. Okay, that is the entire code walkthrough. And again, we're going to build off of this. I'm going to make changes. I'll make update videos, but I had to make one super long, crazy long video there going through each line of code, explaining things as best as I possibly can. Now, again, I'm not taking credit for a lot of these libraries that I used, okay? So, and that's also why I'm not an expert on every aspect of them either. So big shout out to everybody who has ever done anything on the ESP8266, because it really is an amazing platform, and amazing just how much is out there. I mean, it's just crazy. That Wi-Fi Manager library, the client secure library, all of this, all built in, ready to go for you to use. So really great stuff there. That is the video. Thanks for watching.